class, Mrs. Calvi here. This is just a quick tutorial on finding the area of irregular figures. So basically figures that are not shapes that we are aware of and have a formula for. So it's not a square, it's not a circle, it's not a triangle, it's an irregular shape or irregular figure, an odd figure. So I have an example here. This is from actually the honors book. So this is 9.3 for my honors class. 9.3, and it's actually example 2, finding the area of a composite figure. Okay, so if you notice, this is not a figure that we would have a formula for. But what they did is they took this figure and they made it into 2 different figures that we would be able to calculate the area for. So they drew this red line, and now all of a sudden we have a square and then half of a circle. Well, if we know how to find the area of a full circle, in order to find the area of a half a circle, all we would do is calculate the area of the full circle and then divide your answer in half. Okay, and then all we're going to do is add the 2 areas together to get the area of this irregular figure or composite figure. So I am going to go back to my drawing, which is right here. It's pretty sad looking, but it's the best I could do. All right, so we broke this up into 2 figures. So I have my square here and I have my half a circle here. So the first thing I'm going to do, I always write my formulas out, so I have them there to then plug in underneath. So I'm going to write my formulas out. So formula for a square or a rectangle is area is equal to length times width. And then I have to remember the area of a circle. So the area of a circle is pi times radius squared. All right, so I'm going to work with my square piece first, this piece right here. So my area is equal to a length of 12 and a width of 12. So my area of the square part, 12 times 12 gives me 144. And in this case, that would be square meters. All right, so I have the area of my square. I'm now going to calculate the area of the circle. All right, it's technically a half a circle, even though mine doesn't really look like it's half, but it's half of a circle. Well, this part here, this red dotted line, this would be the diameter of the circle, goes straight across, right? And if this is a square, and we know that this is 12 meters, the bottom's 12 meters, the left side is 12 meters, we know that the top would be 12 meters, and then this right side, this red dotted line, would also be 12 meters. So I'm going to actually go ahead and fill in those missing pieces. So this is going to be 12 meters, and then this is going to be 12 meters. All right, so now we're going to calculate the area as if this is an entire circle. So I'm going to go back to my formula over here for my circle. Area is equal to, we know pi is 3.14. So if this red line represents the diameter, we now know that the radius is half the diameter. So if the diameter is 12 meters, we now know that the radius would be half of that, which is 6 meters. And then, of course, we're going to square that. So now we have to do a little bit of math here. This is where you can use your calculator. All right, so it's going to be 3.14. 6 squared means 6 times 6. 6 times 6 is equal to 36. And then when I go and plug in 3.14 times 36 into my calculator, I would get 113.04. Now this is the tricky part. You calculated the area for as if this were an entire circle. You have to remember this is not an entire circle. Technically it's half a circle, right? So from the book, that looks more like a half a circle. Mine really doesn't because I'm not that good at drawing here. So what do we have to still do to this area? We still have to take this area and divide it by 2. So if we go ahead and divide this by 2, our area, technically it's approximate, okay? When we go to do this division, it was 56 26.52 square meters. So we're not done yet because we want to know the area of this entire figure. So we have to now take our two areas and add them together. So let's go ahead and do that. So I'm going to take my area of my square, which was 144, and I'm going to add my 56.52 for my half a circle, and then the area of this irregular figure or composite figure is approximately, it's really approximate, to 200.52 square centimeters. All right, so it seems like it's difficult, but it's really not. You're just going to be given a figure. You're going to see how you can divide it into shapes that you know the formulas for the area. So for example, if I look at some of the other ones in your textbook, on page 369, if you notice here, this is an irregular figure, right? So it's a composite figure. But if you were to draw a line here, this would be a rectangle and then this would be a triangle. You guys know how to find the area of a rectangle and you know how to find the area of a triangle. You just have to then add the two together. Okay, so that's pretty much it for finding the area of irregular or composite figures. Until I talk to you next time. See you guys.